All right, welcome Math 121 to the new and improved way that we're going to do class here with the coronavirus stuff going on. All right, so this is lecture 1 of the new unit where we're going to look at exponential functions and logarithmic functions. So today we're going to look at an exponential function, right? That's what you see up here on the screen right now is this red exponential function. All right, I want to just show you some basics before we get going here. So where we have to remember a little bit here is some properties of exponential or of exponents, okay? So if we have a base, like let's say 3, and then we raise it to the x power, this is what makes something exponential. This is what makes the function exponential. So we get y is equal to 3 raised to the x power, all right? So I just want to show you some things that are going to happen with these numbers as we go through that. So if we put in 1, well, that's the easy one, right? So if I say 3 to the first power, clearly I'm going to get the number 3. Okay, so we know that. That's easy stuff. And we know 3 squared is 9, and we could even do 3 cubed is 27. Okay. Where the real interesting stuff starts to happen is when we put in 0. So when we put in 0 up here, we always get the answer 1. So this point 0, 1 is a critical point for the exponential functions. And this is where we're going to hone in on the function and move it around, all right? You can see that function, that critical point right here. See that point right there? There it is. So the 0, 1 is the y-intercept. It's where we're going to be able to move this function around. So we need to know where that guy's at. Another thing that happens here is we get negative exponents. So if we take 3 to the negative 1 power, what that does is it flips this ratio and then makes the exponent positive. So this is how this would look. See how I just flipped the ratio and then kept it positive? Because remember, positive 3 to the 1 power is 3. So this becomes 1/3. But the most important part here is it's not going to make a negative number no matter what we do. So when we do the 3 to the negative 2, what we're going to end up getting is 1 over 3 squared, which is really 1/9. So it's getting really small, but it can't be negative, all right? It can't be negative. And so what you're seeing here is what creates the asymptote. So we have this asymptote at y equals 0, this blue line here. And what that means is that this function will never, ever cross that line. So you can see as I zoom in, we're never going to be able to touch that blue line with my red line because it's impossible to make a negative number with an exponential, okay? So the things we need to focus on here is exponential functions like to go through 0, 1. And there's two types of exponential functions. If I have a base like this that's bigger than 1, if it's bigger than 1, I get what you see on the screen, a red function that's called the exponential growth function, okay? This is exactly how we could model the coronavirus spread right now, okay? It's an exponential growth curve. Here is what we call an exponential decay model. And notice the only thing I changed was this number here. Instead of 3, we have 1/3. And remember, we call that the base. So what we're saying here is if the base is less than 1, you get a decay. See how it goes downhill? But it still shoots towards that asymptote. And then if it's more than 1, like this one was, you get a growth. And it starts small and it grows fast. So decay is big first and then slows down. See that it's 1/3 is the base. Okay, 3 is more than 1. So this is a growth function. So it starts slow and it grows. But you can tell it doesn't matter if you're growth or decay. We still want to go through that point 0, 1. And that's because anytime I raise something to the 0 power, I always equal 1. So it doesn't matter what the base is. Okay. Now, if the base is 1, then we get, let's just throw that up here real quick. If the base is 1, then we get this weird function. Oh, it's just a constant function where y equals 1 every single time.